Hello friends, I welcome you all to my channel. I hope you are all well and your studies are also going on well. I'm making this video for class CBSE Maths class 7 after a long time. Sorry for the discontinuity. So this video is a part 1 video of the next chapter, that is mensuration. In this part 1 video, I will briefly discuss about the rectilinear figures and we'll discuss about the background of the figures, open figures, closed figures, and what is the fundamental concept of a perimeter and area of a figure, of a plane figure, especially of a plane figure, even though in this chapter we will only deal with simple rectilinear figures. That is, we will know about the formula of perimeter and area of simple rectilinear figures, but in this part 1 I won't discuss about the formula. The formula I will discuss in the next video, that is part 2. In this video I will briefly discuss about the concept of simple rectilinear figures and the concept of perimeter and area. If you are new to this channel or not yet subscribed, and if you like this video and this video is beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay. So before discussing about the perimeter and area of the simple rectilinear figures that we will learn in this chapter, we must understand the basic concept of what a plane figure is, and what are closed figures, what are open figures, and what are rectilinear figures, and what are simple rectilinear figures, and what are the standard figures which are simple rectilinear figures. And then we will understand what it means by the perimeter and area of a plane figure. Okay, so what is a plane figure? So a plane figure is a trace of a curve drawn with a pen on a plane surface without lifting the pen. So for example, if you on a piece of paper, if you draw a line or a curve without lifting the pen, then that trace of the points creates a plane figure. For example, this is a plane figure. So and while drawing a plane figure, when you are drawing a plane figure, it has a starting point and a end point. That is, the point where you started to draw the figure, this was my starting point. So this is I am denoting S with the starting point, and this was my end point of this figure. So let's take another example. Let's say so this figure, this is also a plane figure, as I did not while I was drawing this figure, I did not lifted the pen. And so as you might have already observed, this was the starting point and this was the end point. Now let's say let's draw some few more figures. So this is let's say this is also a plane figure. This was my starting point and this was my end point. Let's see a few more examples. So this is also a plane figure. This was my starting point and this was my end point. Similarly, I hope it is clear what is meant by a plane figure. That is, you are drawing a curve. That is, what is a curve? A curve is nothing but a connection, numerous points connected together. That is a curve, or a trace of a curve. When you draw a curve, that is you are tracing something, or tracing a line or a curve on a paper without lifting the pen. That is basically a plane figure. Okay, now let me quickly draw few more plane figures. So this is a plane figure. This is a plane figure. Now this software recognizes the shape, so it automatically reshaped the figure I drew as a square. Okay. So this is also a plane figure. This is also a plane figure. This is also a plane figure. Okay. Now let's see what cannot be a plane figure. Let's say I am drawing a figure. and at this stage I lifted the pen, and then again I started drawing the figure like this. So this is not a plane figure. This is not a plane figure. This is not a plane figure. Because I lifted the pen, because this figure, whatever this figure is, cannot be drawn without lifting the pen. For example, another figure, and now remember, I am saying that a figure is so the last one, this is not a figure, and all the first 1 2 3 4 5 6 7 8 9, or the first 9 curves are figures. Now there are two words involved. One is plane and one is figure. So figure is a trace of a curve or a trace of a path drawn with a pen without lifting the pen. That is a figure. Now when you draw that path on a plane surface or a piece of paper, then we say it is a plane figure. Okay. So let's say I am trying to draw a triangle, and then at this point I lifted the pen and again I draw this. So this is also not a plane figure. I hope it is clear. This is not a figure. I hope it is clear what is meant by a figure. And since we are what is a plane figure? A figure drawn on a plane surface, like a piece of paper. Okay. Now a figure can be an open figure or it can be a closed figure. Let's see what is an open figure. So for this we need to understand what is the starting and end point of a figure. So I already explained while drawing the figures that when you draw a figure, it has a start point and an end point. So what is an open figure? A figure whose end point do not coincide with the start point is an open figure. For example, this figure is an open figure. As you can see, this was my starting point and this is my end point, and they are not same. Starting point and end points are different. That is basically visually you can say that there is a gap. It is not this figure is not it is open because it is open because the starting point and the end points are different. Let's see a few more examples of an open figure. This is also an open figure, as this was my end point and this was my starting point. So this is an open figure. Let's see. This is also an open figure, as this was my start point and this is my end point. Let's see few more examples. Let's say this is also a open figure because this was my start point and this was my end point. I hope it is clear what is meant by an open figure. That is, in a figure, when you have drawn the figure, the starting point and the end points, they are not the same, they are not coinciding, they are different. Okay, this is an open figure. Let's see what is a closed figure. A closed figure is a figure whose end point coincides with the sorry, start point. So in a figure, if you draw a figure where the start point and the end point they are same, that is, after drawing the figure you ended at the point where you started from. So it is a closed figure. For example, this is a closed figure, as this point is both the start point and the end point. For example, let's say there is a point, this is the point start. I will start from this point. I will draw a figure. I will start at this point and I will also end at this point. So this is a closed figure. So some more examples are, so this is a closed figure. The start point and the end point are same. For example, let's say I will draw a figure. This is the start point, let's say. Even though there is a small gap, I'm sorry, this is the problem with the software. Let me try to draw it again. Let's say there is a point. I will start from this point. So this is the curved path, curved stress, and then from here I am ending at the same point, that is at the starting point. So this is a closed figure. This is a closed figure. So a few more examples could be a star. This is a closed figure, and this is the starting and the end point. Other examples are, this is also a closed figure. Sorry, the shape recognizer is recognizing it as a circle. I'm sorry. Let's say, oh sorry. Anyway, I hope you got the idea what is meant by a closed figure. That is, when you are drawing the figure, the starting point and the end point, they are coinciding. Okay. Now, what is a simple figure? Now, a figure which does not intersect with itself. Which does not intersect with itself. What it means by the fact that a figure intersects with itself. Okay. Let's first try to understand what it. Let's try to draw some figures which intersects with itself. That is, a figure intersects with itself means that when you are drawing the figure, while drawing the figure, you are crossing a part of the figure which has already been drawn. For example, so I am drawing this figure. As you can see, this was the starting point, this was the end point, and at this point, this be O. I crossed at this is the point where the figure is intersecting with itself. That is, while I was drawing the figure, at the point O, I intersected the figure itself. So other examples could be, let's say, I am drawing a figure. I will start from the point S. Now, so this is the figure I am drawing. So as you saw, I ended while drawing this figure. I started at the point S and I also ended at the point S. That is, the starting point and the end points are the same. And also, as you can see, at this point O, the figure is intersecting. The figure is intersecting with itself. The figure is intersecting with itself. Okay. Other examples could be, this is also, as you can see, this point is the starting point and the end point. At this point I started drawing the figure, and I also ended at this point, and this is the point of intersection, that is at this point O the figure is intersecting with itself. So this is what it means by saying that a figure intersect with itself. And so what is a simple figure? A figure which does not intersect with itself. So all these three figures that I have drawn, they are not simple figures. As you can see, they are intersecting with itself. They are intersecting with itself. So what are so let's now try to draw some simple figures. So let's say this is a simple figure, because this is not intersecting. This figure is not intersecting with itself at anywhere. Now remember that a simple figure has nothing to do whether the figure is closed or open. It could be open, or even it could be closed. For example, this is a open simple figure. This is a open simple figure. Okay. Now let me abbreviate some terms for ease of discussion. So this is a simple figure. Let's say SF means simple figure, and so this one is open simple figure. Open simple figure. Now let's try to draw a closed simple figure. So this is a triangle, basically a triangle. This is a closed simple figure. So this point is the starting and the end point. So this is a closed simple figure. This is a correct simple figure. Okay. Some more examples. Let's say so this is the starting and end points, and as you can see, this at no point the figure intersects with itself. So this is a closed simple figure. This is a closed simple figure. Some other examples are this is also a closed simple figure. As you can see, there is no point at which the figure is intersecting with itself. Okay, so I hope it is clear what is meant by a simple figure. What is meant by a simple figure? Okay. Now let's see what is meant by a rectilinear figure. What are rectilinear figures? A figure which is made of only line segments. As you can see, so far we were drawing all the figures. Some figures some figures were drawn using curved lines, and some figures were drawn using straight lines, and some figures were drawn using both curved and straight lines. Now a figure which is drawn or made up of only line segments, those figures are known as rectilinear figures. For example, this is a rectilinear figure, because as you can see, the line segments, this figure is made up of the line segments. If I name the points, this figure is made up of the line segments AB, BC, CD and ED. These are the line segments which is forming this the rectilinear figure. Okay. Let's say now also a rectilinear figure has nothing to do with whether it is a closed figure or it's an open figure. A rectilinear figure can be a closed figure, and it can also be an open figure. The only condition is that the figure in a rectilinear figure, it is the figure is made up of only line segments. Okay. So okay, now let's draw few more rectilinear figure. Let's say okay, so this is also a rectilinear figure. If I mark the points, the EF, so the line segments that is forming these rectilinear figures are AB, PC, CD, DE and EF, EF and of course AF. So we are having 6 line segments which is creating this rectilinear figure. In the first figure we were having 1, 2, 3, 4 line segments. Okay. Let's say this is now please note that I'm not continuously drawing the figure just for the sake of discussion. Let's say AB is a line segment, and then BC is another line segment. I am trying to draw a rectilinear figure by drawing each lines separately, but of course this the complete figure, it will be a figure as it can be drawn without lifting the pen. So let's say AB is one line segment, BC is another line segment, and let's say CD is another line segment. So this is also a rectilinear figure, as this figure is made up of the line segments AB, BC and CD. So it has 3 line segments, and in a rectilinear figure, all the line segments in any rectilinear figure, all the line segments which is creating the figure are known as the sides of the figure. These are known as line segments are known as sides of the figure. So in the first figure, AB, BC, CD and ED, they are the 4 sides of this rectilinear figure. In the second figure, we are having 6 sides, that is AB, BC, CD, DE, EF and AF are the sides of the rectilinear figure. And in the third figure, AB, BC, CD are the sides of this rectilinear figure. Okay, let's draw 2 more rectilinear figure. Let's say okay, sorry. So this is one line segment, this is another line segment, and let's say this is the final line segment. So we are having the line segments, let's say A, AB, BC, CD and AD. So this figure, this is the rectilinear figure where the line segments which is forming this figure is AB, BC, CD and AD. So AB, BC, CD and AD are the 4 sides of this rectilinear figure. Okay. Okay. Let's draw one more rectilinear figure. Okay. So this is one line segment, let's say this is another line segment, this is another line segment, let's say this is another line segment, this is another line segment, and this is another line segment. So AB is one line segment, BC is another line segment, AC is another line segment, BD is another line segment, and DE is another line segment, and CE is another line segment. So the line segments that is forming this rectilinear figure are AB, BC, AC, BD, DE, and CE. So this rectilinear figure has 1, 2, 3, 4, 5, 6 sides, that is AB, BC, AC, BD, DE, and CE are the sides of this rectilinear figure. So the line segments which is forming a rectilinear figure, they are known as the sides of the rectilinear figure. I hope it is clear what is meant by a rectilinear figure. Remember that a rectilinear figure can be open and it can also be closed. Okay. Now is what is meant by a simple closed rectilinear figure. So all the special figures that we will study, whose formula of area and perimeter we will study, they are basically simple closed rectilinear figure. Okay. So what is simple closed rectilinear figure? As the name suggests, a rectilinear figure which is closed and simple. So the figure must be a rectilinear figure, that is, it is made up of only line segments, and the figure must be closed. It must be closed, that is, the starting and the end point must be the same, and the figure must not intersect with itself. Okay. So some examples of simple closed rectilinear figures are, so let's say I am drawing a simple closed rectilinear figure by drawing the line segments separately, individually. So this, let's say AB is one line segment, and say BC, basically, so this is a triangle NAC. So this is a simple closed rectilinear figure. As you can see, now even though I did not even though it is not I cannot tell which I don't know what was the starting and the end point, because I have drawn the line segments individually, separately, but anyway, I hope you can understand that this is a this is a closed figure, and it can easily be drawn. I can start from the point A, and again this figure can be drawn where the starting point and the end point can be any one of the points A, B, or C. So this is a simple closed rectilinear figure. Okay. So this is a simple closed rectilinear figure. So I am abbreviating RF as the rectilinear figure. Let's abbreviate RF for rectilinear figure. Okay. So this is a correct simple closed rectilinear figure. Now is this so this was the starting point and this was the ending point. Is this a simple closed rectilinear figure? No, because this is a rectilinear figure. As you can see that let's mark these 2 points at A and B. As you can see that this figure is made up of the line 3 line segments, that is AB, SB, and AE. So this is a rectilinear figure. This is a rectilinear figure. So I can say that this is a rectilinear figure. This is a rectilinear figure. And is this a closed figure? Is this a closed figure? No, because we can see that the starting point and the end points are different. So this is definitely not a closed figure. And so we can immediately say that this is definitely not a simple closed rectilinear figure. If it is not a, if the figure is not a closed, then definitely it will not be a simple closed rectilinear figure. And also you can see that this figure is also not a simple figure. This is also not a simple figure because this point, at this point O, the figure is intersecting with itself. Okay, let's see another example. I have this, let's say I have drawn, okay, is this simple closed rectilinear figure? Let's abbreviate this as simple closed rectilinear figure. Is this a simple closed rectilinear figure? As you saw that I started at this point. This was my starting point and this was my end point. This was my end point. And okay. Also notice that this is my end point, the point E is the end point, and it is also the point of intersection, because at this point this figure is intersecting with itself. Now please note that when do we say what is let me clarify a bit more what exactly is the point of intersection, what exactly is the point where a figure intersects with itself. Let's go back to the point where we were discussing about simple figures. Okay, so we were discussing about simple figures. Okay, now let's say I am drawing a figure. Let's say I started at this point. I will start at this point S, and let's say I did this. Now you might ask that so it is clear that the ending point and the starting point coincides. That is the end point where the end point of the figure is the same as the starting point of the figure. Now can we say that this figure is intersecting with itself at the point S or E? At the point S or E? No, because if the starting point and end point, if the starting point and end point coincides, that can never be the point of intersection. That is, that cannot be the point where the figure is intersecting with itself. It has to be any other point. That cannot be the point where the figure, we never say that at that point the figure is intersecting with itself. But let's say this is the starting point. I have drawn this figure. As you can see that this is the end point. This is the end point. But since this end point is not same as the starting point, it is different from the starting point, and this point is E, the point E. I ended at a point E where, and that point E is intersecting the line segment. Let's say if this point is A and this point is B, so the point E is on the line segment SA, which was already drawn. While I was drawing, how did I draw this figure? First I draw the line segment SA, then I draw AB, and then I draw BE. But when I was drawing BE, E was the end point of the figure, and intersected the line SA, which was already drawn. So in this case in this case E will also be the point of intersection, that is at the point E or O. This figure is intersecting with itself. This figure is intersecting with itself. Only when if but remember that when if the point if in a figure the starting point and the end point coincide is the same, then the starting point or end point is never the point of intersection. That is that we never say that the figure has intersected itself at the starting point or end point if starting point and end point are the same. For example, let us say I am drawing a figure like this. So, this will be my starting point. Let us say this is my starting point and I am drawing the figure like this. As you can see that I ended the figure where the end point is also the starting point, that is the starting point and end point are coinciding. So the S and E will never be a point where we say that the figure is intersecting with itself, but this is at this point the figure we say that is intersecting with itself. So point O is the point of intersection. By point of intersection I mean that the figure is intersecting at that point itself. Okay. So now So this figure, the third one, as you can see that the starting point is S and the end point is E, and since the starting point and end point are different, and the point E has intersected the line segment. Let's say this is SA and this is B and C has intersected the line segment SA, which was already drawn. We say that the point E is a point at which the figure is intersecting with itself. So this is definitely not a simple figure. This is not a simple figure. And is this a closed figure? No, this is not a closed figure because the starting and end points are different. And is this a rectilinear figure? Of course, this is a rectilinear figure because this figure was drawn using only line segments, and hence since it is not a simple figure and also it is not a closed figure, so definitely it will not be a simple simple closed rectilinear figure. So this is not a simple closed rectilinear figure. Okay. Now let's quickly draw a few examples of a simple closed rectilinear figure. So this is a simple closed rectilinear figure. As you can see that this figure is made up of the line segments AB, BC, CD, DE and AE, and there is no point at which the figure is intersecting with itself. As you saw that the point A is basically was the starting point and the end point. Okay. So a square, as you know, it is also a even though this is not looking like a square, please assume that this is a square. So this is also a simple closed rectilinear figure because this figure is made up of let's say this is A, B, and let's say this point BA, which is also the starting and the end point. Let's say this is B, C and D. So this figure square is made up of the line segments AB, BC, CD and AD. I hope it is clear what is meant by a simple closed rectilinear figure. Okay. Now let's try to understand what is meant by a perimeter of a figure. Now please note that the perimeter So what is perimeter of a figure? Perimeter of a figure. By perimeter of a figure, we mean the length of the boundary of a figure. The length of the boundary of a figure. Now, the perimeter is defined for any figure. It need not be closed, or it has nothing to do with whether the figure is closed or it is open, or it is simple, or it is a rectilinear figure. Any figure has a perimeter. Any figure has a perimeter, and so the length of the boundary of the figure is its perimeter. Now let's try to understand what is meant by the boundary of a figure. Okay, let's draw some simple. Let's draw few figures. Let's say I have drawn this figure. So definitely this is a figure. This was my starting point. Of course, this is not a closed figure. This is an open figure, because this was my starting point and this is my end point. Now, what is the boundary of this figure? The boundary, let's say now, so AC is a straight line. AC is a straight line. Let's give it a different name. Let's say SAB. Let's take another point on this curved line, not O but C. So in this figure, let's say AC is a line segment. AC is the line segment, AB is the line segment, and BCE is a curved line. So as you can see, so SA and AB are line segments, and BCE is a curved line. So what is the boundary? What is the boundary of this figure? So boundary. So boundary, as you can see, the boundary is SA and then AB, SA, AB, and then this curved line. This is the boundary. So the perimeter, let's say we denote perimeter. We denote perimeter with the letter P. So perimeter P of this figure will be the length of the line segment SA plus the length of the line segment AB plus the BCE. The curved, let's say the length of the curved line BCE. Now, as you know that in a figure, some part could be curved and some part could be straight. So now let me. I hope you are getting the idea what is meant by the boundary of a figure. So for this figure, the boundary will be. I'm trying to visually explain what is the boundary of this figure. So the boundary of this figure is the line segment SA. From S, you go to the point A. So SA, the line segment SA, and then from A to B, you go you go to the point B. So you traveled across the line segment AB, and then from B to E, from B you go to the point E along the curved line, that is BCE. So this is the boundary of this figure. Now, since SA is a line segment, SA plus AB, so the length of this boundary is the perimeter of this figure. So SA is nothing but the length of the line segment SA, AB is the length of the line segment AB, and BCE is the length BCE. By BCE, this BCE, I mean it is the length of this curved line. Now if you stretch, what exactly is BCE? BCE is if you stretch this curved line BCE as a straight line, then the length of the straight line is actually the BCE. That is, BCE is actually denoting the length of the curved line BCE. Okay. Now let's say another example. Let's take another example. So let's say this is a figure. This is definitely not a closed figure. This is an open figure, but this is a rectilinear figure. Now let's say the points are this. Let's say the line segments which is forming this figure are AB, BC, CD, and DE. So what will be the perimeter? So what is the boundary of this figure? What will be the boundary of this figure? So perimeter for this figure P will be equal to boundary. Okay, so it will be AB, that is the length of the line segment AB, plus BC plus DC plus ED. This is the perimeter of this figure. Okay, now let's take some very known figures. Let's say this is a rectangle. Let's say the line segments that is forming this rectangle or this rectilinear closed figures are AB, BC, CD, and AD. So the perimeter P will be equal to AB, that is the length of the line segment AB, plus BC plus CD plus AD. Okay. Let's take another example. Let's take so this is a curved line, and let's say we have this line segment, we have this line segment again, we have this line segment again, we have this line segment again. So let's say this figure is formed by, as you can see, this is not a rectilinear figure because this figure is not formed by is not formed by only line segments. It also has a curved line. So let's say let's take a point B on this curved line. ABC is a curved line, and let's say this is D, and let's say this is E, and this is F. So this figure is formed by 4 line segments, that is AD, DE, EF, and FC, and one curved line, that is ABC. So what will be the perimeter? Of this figure? Perimeter of this figure will be the length of the line segments, that is AD plus DE plus EF plus FC, and then the length of the curved line, that is ABC. Now length of the curved line ABC. Okay. Perimeter. Okay. Now let's take one more example just to clarify what exactly the perimeter of a figure is. Let's say we have this figure. Let's take, suppose this is a square, and then let's take sorry let's say this is the figure. Now please note that this is a figure, that is you can draw it without lifting the pen. Now let's say and of course this is a rectilinear figure. Let's say this figure is formed by the line segments AB, let's say AB, and let's say AB, BC, CD, DE, EF, FG, AG, and FC. Now what I have no space. Okay, so what will be the perimeter of this figure? This is a rectilinear figure, and of course this is also a this is definitely not a simple figure, because this figure is intersecting with itself. This figure is intersecting intersecting itself at the points F and C. So this is not a simple figure, but this is a rectilinear figure. Remember that perimeter is defined for a figure. Any figure has a perimeter, that is the length of its boundary. Now given a figure, you must properly understand what is its boundary. Now if the figure is closed, now this is a closed figure, but even though this is not a simple closed figure, as it is not simple because it is the figure is intersecting with itself at the point F and C, but it is a closed figure. For a closed figure, the boundary will not include any part of the figure which is inside the figure. Now by that I mean that for this figure, the perimeter P will be AB, that is the length of the line segment AB, plus BC plus CD plus DE plus FE plus GF plus AG. It will not include FC. Because the part FC is inside the closed figure. This is a closed figure. And the part FC is enclosed, is inside the closed figure. So this thing you should be very clear about what exactly will the perimeter of a given figure will be, or the boundary is, or what will be the boundary of a given figure. And what is perimeter? Perimeter is nothing but the length of the boundary. Okay. Okay. Next, what is area of a closed figure? Now, to understand the area, now please note that area is only meaningful for a figure which is closed. Area is not applicable. Area is meaningless for an open figure. It is only meaningful for a figure which is closed. So, what is area? Area is the measurement of the region enclosed by the boundary of a figure. Now, by a figure, it has to be, of course, a closed figure. Now, we need to understand what is the region enclosed by the boundary of a figure, boundary of a closed figure. So, whenever we find the area of a figure, that figure obviously has to be has to be closed, but that figure may be simple or it may not be simple. So let's say we have this figure. As you can see that this figure this is a so this is a rectilinear figure. This is the rectilinear figure, but this is not a simple figure, as it is intersecting. The figure is intersecting at itself at the point, at this point O. Now let's say the line segments forming this figure, is, let's say, AB, this is C, D and O. Okay. So what we we need to understand what is meant by the region enclosed by the boundary of a figure. The region enclosed by the boundary of a figure. Now, since we are only dealing with a closed figure, so the region for this figure, the region enclosed by the boundary of the by the boundary of the figure will be this part. And also this part. So the shaded part is the region enclosed by the boundary of this figure. So the shaded part is the region enclosed by the boundary of this figure. Now, so the measurement of this region, is actually the area of this figure. Now, what exactly is the measurement of the region, we will discuss a bit later. Okay, let's see few more examples of closed figure where and try to understand what is the area. So let's say we have we have a figure like this. Let's say this is the figure. Of course, this is a closed figure. So as you can easily understand that the region enclosed by this figure, this is a closed figure, but this is not a rectilinear figure because there is a curved part. This figure is not made up of only line segments. So this the shaded region, so the shaded part, so this is the region enclosed by the boundary of this figure. To find the area of a given figure, you must clearly understand what is the region enclosed by the closed figure. Okay, now let's see. Okay, let's see this figure. So this is also a closed figure, but this is not a simple figure, as this figure is intersecting itself at this point. But still, this figure is a closed figure, and the region enclosed by this figure is this part, this shaded part. This shaded part is the region enclosed by the boundary of this figure. Okay. Let's try to see few more examples. So let's so a circle, let's say we have a figure. This is let's say we have a figure like this. Let's say so this is a definitely this is a closed figure, and but this is not this is a closed figure, but this is not a simple figure. At this point, let's say at this point the figure is intersecting with itself. Now let's say so what will be, let's say let me properly draw the figure so that we can clearly understand what will be the region enclosed by the figure. Let's say we have let's say now this is simple. You can clearly understand what will be the region enclosed by this figure. Obviously this part is the region enclosed by the boundary of this figure. So this is the region, the shaded part is the region enclosed by the boundary of this figure. Okay. Let's say we have a figure like this. This is a figure. Let's say we have this figure. This is a closed figure, but of course this is not a simple figure, as this figure is intersecting itself at these 2 points, but this is a closed figure. So what will be the area enclosed by the boundary of this figure? It will be this shaded part. Now I am illustrating, I'm explaining the area, I'm illustrating, I'm demonstrating with these examples just to give you the basic concept of what is area is. That is what area is nothing but a measurement of the region enclosed by the boundary of a closed figure. So I am just trying to explain what is a region enclosed by the boundary of a closed figure. So for this figure, this shaded area is the region enclosed by the boundary of this figure. I hope it is clear. Let me see if I can draw few more examples. Now okay, let's see what will be the, let's say I draw a figure like this. Let's say let's say let's say I draw a figure like this. So this is a square. I have completed a square, but then it may not be a square. Let's say this is a rectangle, but then let's say so this is let's say this was the starting point. This was the starting point. So I draw this rectangle. I came back to the starting point S, and then I, let's say, draw again the line bed. Let's say this, and this. So let's say I have drawn this rectangular figure. So the S is the starting point. I have drawn this rectangular figure. So I am at the point S. and from S again I draw the line segment, let's say this, and then let's say this. So basically, let's say if the corner, if the line segments are, let's say, S A, B, C, T. So I started while drawing this figure, I started at the point S, but I ended at the point C, because after drawing the rectangle, that is the SABC, again I came to SABCS. I came back to S, and from S again I draw the line segment SD, and again the line segment DC. So for this, this is a plane figure. This is of course this is now is this a closed now first of all, is this a closed figure? Is this a closed figure? Because I started at the point S. Let's not take this example. I am a bit confused to justify whether this figure is a closed figure or not, because I started at the point S, but I ended at the point C, even though while drawing the figure, that is the outside rectangle SABC, I came back to S. When I started from S and again came back to S, then a closed figure was already drawn, that is SABC, but from S again I draw the line segments SD and DC. But anyway, I was trying to say that for this figure, what will be the region enclosed by the closed figure. Anyway, let's not take this example. I'm really not sure whether this figure is a closed figure or not. Because the figure was closed when the rectangle SABC and then S was drawn. Anyway, let's not discuss about this figure. I hope you got the basic idea what is meant by the region enclosed by a closed figure. Region enclosed by a closed figure. Let me draw a few more examples. Let's say I draw this figure. So this is a curved let's say okay, so let's say this is a circle. I have drawn a circle, and let's say the figure I'm trying to draw is, let's say is like this. So this is the complete figure where you can say that how did I draw this figure. Let's say I started at this point S, and then I draw the curve S C. Let's say this point is uh, okay, let's not take this example. Let's say I draw this figure. I have these, let's say I have this curved line. Sorry, let's say I have this curved line, and then let's say I have this curved line, this one, and then I am this part is the straight line, even though it is not looking like a straight line. So I started at this point. So this is the starting and end points, and let's say this is this B, and let's say a point somewhere on this part, that is SCB is a curved line, and AC and SB or EB is the line segment. So what will be the, and this figure is not, definitely not a rectilinear figure, because this figure is not formed by only line segments, but it is a closed figure as the starting point and the end points are same. So it is a closed figure. So we can, a region enclosed is only applicable, is only meaningful for a closed figure. So what will be the region enclosed by this figure, by the boundary of this figure? This is the shaded part. This part is the region enclosed by the boundary of this figure. This is, I am just trying to explain what is the region enclosed by the boundary of a closed figure. Okay. Now, and what area is? Area is just a measurement of is the measurement of the region enclosed by the boundary of this figure. Now, okay. Now let's see what are the standard units of perimeter and area. So perimeter, as you know, it is just as the definition says, that the perimeter is the length of the boundary of a figure. So definitely it has units of length. Now the standard units of perimeter, are centimeter or meter. So I have drawn two figures. The first one, as you can see, this figure, the first one, this figure is a rectilinear figure, but it is not closed, it is open. And as you can see, so what will be, so this figure is made up of the line segments AB, BC and CD, and the length of the line segment AB is 3 centimeter, the length of the line segment BC is 1 centimeter, and the length of the line segment CD is 4 centimeter. So what will be the perimeter of this figure? It will be the length of the boundary. So what is the boundary of this figure? The boundary is nothing but the line segments AB, BC and CD are forming the boundary of this figure. So the perimeter will be the sum of the line segments of the sum of the line segments AB, BC and CD. So it will be, so the perimeter will be 3 centimeter, that is the length of the line segment AB, plus the length of the line segment BC, which is 1 centimeter, plus the length of the line segment CD, which is 4 centimeter. This is equal to 8 centimeter. So the perimeter of this figure is 8 centimeter. In the second figure, we see that it is not a rectilinear figure, as there is a curved path. So this figure is formed by the curved path. The curved path is POR. POR is a curved path, and let's say the length of the curved line or curved path POR is 12 meter, and we have two line segments PQ and QR. So PQ, the length of the line segment PQ is 2 meter, and the length and also the length of the line segment QR is 2 meter. So this figure is a closed figure. This figure is closed figure, but it is not a rectilinear figure. So what will be the perimeter of this figure? So we must first understand what will be what is the boundary of this figure. So the boundary is made up of the curved line or the curved path POR and the line segments PQ and QR. So the perimeter obviously will be POR, perimeter will be the length of the curved line or path POR, which is 12 meter, plus the length of the line segment PQ, which is 2 meter, and the length of the line segment QR, which is also 2 meter. So this is equal to 16 meter. So the perimeter of this figure is, of this closed figure, is 16 meter. This is just to explain with some example what is the perimeter of a so how do we calculate the perimeter of a given figure in terms of the length of its boundary using the units of centimeter and meter. Okay. So what is the standard units of area? The standard units of area is square centimeter or square centimeter. This is in short form also written as SQ cm, as cm is the symbol of centimeter. So SQ cm is in short form of the square centimeter, and also it is also written as cm square. Okay. And the another unit is square meter, or another form is SQ square meter and meter square. So these are the two standard units of measuring area of a closed figure. For example, the area of a square of whose side is of 1 centimeter length is equal to 1 centimeter square, and the area of a square whose each side is 1 meter, the area is 1 meter square. Okay. So this was just about a very introductory video discussing about the concept of the figures, closed and open figures, simple figures, rectilinear figures, and the concept of perimeter and area of a closed figure. In the next video, I will discuss about the formula of discuss about the perimeter and area of the square and rectangle, and the formula to find the perimeter and area of a square and rectangle. If this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. Please stay tuned for the next video, where I will discuss about the area and perimeter of square and rectangle, and the formula how to find the area and perimeter. I will end the video here. Thanks for watching, and until the next video, take care and bye.